So, we here. In the last video, we would have derived certain trigonometric ratios for 30 degrees, 60 degrees, and 45 degrees. Starting off with ratios that we are aware of. We know, for example, that the sine of 30 is a half. We started from that and we went through. We know that the cosine of 60 is a half. We started with that and we went through. We know that the tan of 45 is 1. We started with that too and we went through. So now we want to make the switch from degrees to radians. Remember, in an earlier video, we started off from pi radians equal to 180. Well, 180 degrees equal to pi radians. And we went down to pi on 2 and pi on 4 and pi on... We went all the way down. We full up the whole board. That's the small board. We use the small board with that one. And we went to all... Little man, we had real fun on that video. Here is one of the first places in the AdMath syllabus where we started getting to using the radians. Using the radians in terms of trigonometric identities. Now you would have used the radians in questions where you had to find the area of a sector and the length of an arc. Alright? The perimeter of some shape where the circumference of a circle was part of the perimeter or whatever, right? So, or the area of some kind of compound shape where a sector of a circle was, a sector or a segment of a circle was part of the shape, right? We use radians for that too. But here now is where we get into radians in terms of knowing these ratios and expressing them in radians. So we start with degrees and we know that 30 is pi on 6. So all we do, having gone through this for 30 degrees, is replace 30 degrees by pi on 6 and boom, in radian territory. So watch it now. All we do is this. You move this 30, you place this 30, and instead of 30, you now have pi on 6, sine pi on 6, cosine pi on 6, tan of pi on 6. You do the same thing for 60. You know that 60 degrees is pi over 3 radians, as discussed earlier on. So watch it now. We just take the 60 and replace it with pi on 3. Pi on 3, pi on 3, pi on 3, and we replace the 60 here with pi on 3 as well. Alright? So this here is pi on 3. And we know that 45 degrees is pi on 4. So we do the same thing across here. We replace 45 degrees with pi on 4. Right? So we're not going to say pi on 4 degrees, it's pi on 4 radians. So anytime you see an angular measure in terms of pi, bet your bottom dollar that they're talking about radians. Alright? Unless, that is hardly likely, so I wouldn't even bother to consider that. Right? Want to see pi in an AdMath context, tell yourself it's radians. Alright? Nice. So this will be pi on 4, pi on 4, pi on 4, pi on 4. Alright? So we now made the shift, having started from degrees, we shift from degrees into radians. So we can say that the sine of pi on 6 is a half, which means that the cosine of pi on 6 is root 3 over 2, and the tan of pi on 6 is 1 over root 3. The cosine of pi on 3 is a half. The sine of pi on 3 is root 3 over 2. The tan of pi on 3 is root 3. All right? And of course, we do the same thing for pi on 4. On the other end of the board, tan of pi on 4 is 1, cosine of pi on 4 is 1 over root 2, and sine of pi on 4 is 1 over root 2. Of course, we also have to consider the situation where we rationalize the surd. So my first port of call would normally be to leave the ratios with the surd in the denominator. That way you could make the direct connection between the value that you have in front of you and the value as derived from the triangle, the right angle triangle, using the appropriate angle. However, once you're dealing with surds, you need to be aware of the rationalized version. So in this case, 1 over root 2 would be the same thing as root 2 over 2. Right? We could put that in brackets. 1 over root 3 would be the same thing as root 3 over 3. You could put that in brackets too. All right? Everything else, we have integers in the denominator. So tan pi on 6 or tan 30 degrees, 1 over root 3 is the same thing as root 3 over 3. That's the rationalization of the surd. Cosine and sine of 45 degrees, both of them being equal to 1 over root 2. We rationalize this and we get root 2 over 2. So again, you have the opportunity now to be aware of all of these different forms, of all of these different ratios. And so now we're in a position where you could start positioning yourself to use these things in the course of solving problems. So by the provision of these videos, I would have given you the platform that you can use to make the first step, to make the first jump. All right? But the next jump is yours. The next step is yours. You have to go there and find questions. You have to go there and find past paper questions, questions from a textbook, etc., etc. All right? And that's basically it. All right? So I hope that you would have been starting to enjoy the mathematics. All right? We're looking to break down the add maths as much as we can, show you how nice the thing is, and use that now to encourage you to go there and do the work that is necessary to be done to get the results that you're looking to get. All right, so as always, take care. We hope to see you back again for some more videos on the CSEC Add Maths syllabus.